Okay, in this one, I wanted to show what the derivative with respect to x of ln of x is. So the first step is to write ln of x as a relationship between x and y. So what that would look like is y is equivalent to ln of x. And I don't want to write it as f of x equals ln of x because I'm going to be taking derivative of both sides and it might be a little bit more confusing. Also because y is going to eventually become a power. So yeah, that's the reasoning behind that. And just by basic logarithmic rules, we can rewrite this as by multiplying both sides by e. So on the left-hand side, what would end up happening is y would become a power, right? It would be e to the y. And that would be equivalent to, well, if you multiply ln of x by e, the ln and the e would cancel out, and you would just be left with x. And this equivalency is going to be pivotal in the next couple of steps. And yeah, so just keep that in mind. So the next thing we can do is now it's in a form that we can actually take the derivative of. And so we'd have the derivative with respect to x of e to the y equals x. So we're taking the derivative with respect to x of both sides. So when you're taking the derivative with respect to x of a y term, similar to how you would do it in implicit differentiation, obviously it's not implicit differentiation because the x and y's are not intermingled. They're isolated on either side of the equation, or the equal sign, sorry. And so what you would do is you take the derivative of the y term regularly, but when you do that, you would also multiply by dy dx. So dy dx. I see also it written as y prime. Either way it works. Just a different notation, I guess. So if you take the derivative with respect to x of e to the y, you would just get e to the y dy dx. And then you take the derivative with respect to x of x, and that's just 1, right? Because if you take the derivative with respect to x of x, it becomes, you bring the power of 1 down, you take away 1 from that, and you just get x to the 0, which is just 1. Yeah, and that should really just be review. So yeah, that's what the right side is equivalent to. So the next thing we need to think about is this statement here, e to the y equals x. So if we have e to the y here, we can simply just say let e to the y equal x and plug it in. Because remember, we want a slope to be in terms of x rather than y. So that's why we're doing that. So we get x dy dx, and that's equivalent to 1. And now you would want your dy dx on one side, and then whatever that would be equivalent to on the left side or on the right side. So you just divide both sides by x, and you'd simply just get dy dx is equivalent to 1 over x, which can also be written as x to the negative 1. So yeah, there you go. That's the derivative with respect to x of ln of x. And really, if you do the antiderivative, or if you take the integral, so if you take the integral from 0 to x of 1 over x dx, you would end up with what we started with, ln of x. And so that just really shows it. I'm not going to prove it, but it is a true statement. So yeah, I hope that helped, and bye.